Hi, my name is Rob Zarnecki, and I'm a product manager with Amazon S3 Glacier. And today I'd like to talk a little bit about our newest S3 storage class, S3 Glacier Deep Archive, which is the cheapest object storage available in the cloud today. Glacier Deep Archive is just about 3 weeks old, and it's growing more than 3 times faster than any other storage class we've launched since S3 was first released 13 years ago. Just to briefly talk about what we'll discuss today, first an introduction to just what Glacier Deep Archive is. We'll spend some time talking about how to use Glacier Deep Archive, the support from the Amazon Partner Network, a bit about the economics of this low-cost storage service, and a few example use cases. So what is S3 Glacier Deep Archive? It's a new S3 storage class with the lowest cost storage available in the cloud, even lower than you can find in on-premises tape, which means that you no longer have to manage tape. A lot of customers have told us that they don't want to maintain magnetic tape libraries or manage off-site tape storage arrangements. They've told us that maintaining this tape infrastructure is difficult and time-consuming. The tapes degrade if they're not properly stored. They require multiple copies, frequent validations, and periodic refreshes to maintain data durability. It's also difficult or impossible to do machine learning and other types of analysis directly on data that's stored on tape. And these systems often require a lot of human effort to maintain, scale, and migrate your data. Retrieving data from offsite tape storage can also be very expensive, take a long time, and require multiple requests to actually identify the right piece of media. Many customers are looking to the cloud to innovate and increase the value of their archives while decreasing the time they spend managing this type of infrastructure. It's a classic example of undifferentiated heavy lifting. And with Deep Archive, customers can repurpose that effort on work that differentiates their business, knowing that they can easily retrieve the data that they need. S3 Glacier Deep Archive replicates your data across at least 3 availability zones within a single region, which gives you unmatched resiliency to single data center issues like power failures. It also has the same design for 11 nines of durability, which other S3 storage classes offer, and provides the same security you've come to expect from the other S3 storage classes. Like Glacier, Deep Archive is designed for 99.99 availability, and it's backed by our S3 availability SLA. Importantly, and unlike tape, Deep Archive allows you to get exactly the objects you request within 24 to 48 hours, depending on the speed of the restore, as opposed to having to do it in days or weeks when managing an off-premises tape storage solution. And Deep Archive provides the same performance that you get with Glacier while costing less than 1/10 of a cent per gigabyte per month, which translates to about $1 per terabyte a month. So to recap, Glacier was the best value archive storage offering before. Deep Archive provides all the same benefits at 1/4 of the monthly storage cost, with all the same security, durability, and availability you've come to expect. We think that you'd have to be out of your mind to want to manage your own tape moving forward. So now that we've talked about what Glacier Deep Archive is, let's talk about how to use it. It's very similar to S3 Glacier in that it's an asynchronous storage class, which is different from our frequent and infrequent access storage classes. But interacting with it is so similar to S3 Glacier. You really just change the enum for the storage class from Glacier to deep_archive, as you can see right here. The other 3 differences are, first, as compared to Glacier, there is no concept of expedited retrieval. As many of you know, Glacier has 3 retrieval options: expedited, standard, and bulk. And the faster the objects are returned to you, the higher the price of that retrieval is. Because there's nothing expedited about Deep Archive, these are meant to be objects that you do not ever expect to need quickly, and in fact may touch very infrequently, if at all. We've eliminated the concept of an expedited retrieval, and just provided the same standard and bulk options as Glacier with a slightly different time to access your bytes. The next difference is the minimum duration. Again, with Glacier, we require that your storage remains in the class for at least 90 days. And as with Glacier, you're not prohibited from deleting your data early. So if you have a requirement, perhaps GDPR or something else, that you need to dispose of the data, you're able to. However, we will accelerate the charge for the remainder of that 180-day minimum duration period and apply it to your bill the day the delete is made. The third difference is that Deep Archive does not support the Glacier Select feature today. So a bit more about how to use Deep Archive. And again, much of this applies to Glacier given the similarities. So I'll highlight the distinctions as we go through. It's important to remember that we have so many customers who are using Glacier today. We intentionally designed Deep Archive to be very similar in an effort to reduce the adoption challenges that a new storage class might present. So if you have an existing workflow and are using Glacier today, our hope is that it'll be a very easy shift to incorporate Deep Archive in your workflow. So first, getting your data into Deep Archive. Like Glacier, there are generally three different paths in. First, you can directly put your objects into Deep Archive. And like Glacier and the other S3 storage classes, you can either do this as a single request or a multi-part upload for a larger file. Put to Glacier was a new feature that we announced at reInvent in 2018, and we're pleased to offer the direct put capability to Deep Archive at launch. As well as the put, you can also copy or cross-region replicate that data into Deep Archive, which is great for data that's already in a frequent or infrequent access S3 storage class. For example, intelligent tiering, S3 standard, S3 infrequent access. Or you can set a lifecycle policy to automatically move your data into any other storage class, including Deep Archives. And one thing that I think is really interesting about this launch is for the first time, you can set a lifecycle policy to move objects which are in Glacier to Deep Archive. If you look at this diagram on the right side of the screen, the previous version before Deep Archive was released ended at Glacier. And I like to describe it as all lifecycle roads can point to Glacier, but nothing can move out of Glacier using a lifecycle policy. Now we've replaced Glacier with Deep Archive there and allowed lifecycle rules to move bytes from Glacier into Deep Archive, which is a great way to design a workflow that could keep your data in Glacier for a period of time where you might need that expedited restore option to get certain small objects back in 1 to 5 minutes, or the Glacier standard restore where you'll get your bytes back in 3 to 5 hours as opposed to the 12 hours in Deep Archive standard restore. And then after a certain point of time where you believe it's not likely to need access that quickly, a lifecycle policy can automatically move those objects into Deep Archive and enjoy the savings of the Deep Archive storage price. To get it a little bit deeper on how the cross-region replication works, remember, cross-region replication is a policy. You can configure it by bucket, by prefix, or by tag. So you can be fairly granular about how that policy applies. And you can set it to replicate data as it's ingested into a bucket directly to Amazon S3 Glacier Deep Archive in another region, which is a fantastic way to make sure that you have a backup in the event of a disaster in your current region or some type of malware or other unfortunate incident that leaves your data compromised. And because you can go directly into Glacier Deep Archive, there's no need to replicate into a warmer storage class and then rely on a lifecycle policy in the target bucket. Another nice thing to think about when designing cross-region replication policies are that you can change the ownership of the bucket in the destination region, which is a great way to prevent the accidental delete star.star or similar scenario, which can result in a loss of data. Moving on to lifecycle policies, they're very similar to cross-region replication in that you create a rule to automatically transition or expire your storage that, again, can be configured by a bucket, prefix, or a tag. I do want to stop for a minute on the expire portion, because it's our hope that in providing Deep Archive, customers will expire less often, or at minimum wait longer to expire, because with such a low-cost storage option in Deep Archive, it's more likely that data may be valuable compared to the low cost of Glacier Deep Archive. And again, lifecycle rules can be set to make multiple transitions, and they take action based on the age of the object. So in this example here, your data will be stored in S3 standard at ingest. For 30 days, you'd enjoy the frequent access, the ability to get and not worry about any retrieval or bytes streamed back costs. After 30 days, it would be transitioned to S3 infrequent access, because you expect that the access would be lower. However, you still might require that object back within milliseconds, and S3 infrequent access provides that millisecond response when you do need the data. But after 90 days, you feel comfortable moving the data into Glacier Deep Archive and enjoying that low-cost archival storage, because you believe it is both unlikely that you'll need that data, and also you're tolerant of a 12 to 48 hour retrieval time in the event that you do need that data back. In another scenario, you can use our S3 intelligent tiering storage class to hold the data for a longer period of time. And what intelligent tiering does is it automatically moves the data between an S3 standard frequent access experience and an S3 standard infrequent access pattern, depending on your usage. And after 180 days, it's safe to go to Glacier again to have the option to make that expedited retrieval, or to make the standard retrieval and get your bytes back in 3 to 5 hours. But after 2 years, it's safe to move it to Deep Archive and enjoy those cost savings in return for the latency. So with that, let's do a quick demo on how to get your bytes into Deep Archive. So I've logged in here to the S3 console, and as you can see, I've created a Glacier Deep Archive test bucket here. And there's already one object that I uploaded before, but let's send another. And we'll take this file with some AWS architecture icons. So this is the normal S3 flow. You select your file. You can add more than one if you have others. You can manage the users who have access, other accounts, public permissions. Again, no difference here from the usual S3 workflow. And when you get to the storage class decision, you have a selection among any of our S3 storage classes. So for this object, I will send it directly to Glacier Deep Archive. You'll see that there's a description to clarify the difference between Glacier and Deep Archive, which again, Glacier gives you the option to access your bytes within minutes. Deep Archive is for that data that retrieval time, you're able to tolerate a retrieval time within hours. You'll see that both are at least 3 availability zones and the minimum storage duration change that we talked about. So there's one file, it's 16 megabytes, and I will go ahead and upload. You'll see a little upload status bar at the bottom of the screen here, and now we have 2 objects in my bucket, and you can see that both are in the storage class Glacier Deep Archive. You'll notice that if I select this object, it gives me the object URL. Again, like Glacier, Deep Archive is an asynchronous storage class. So if I try to open this URL, it will fail because the document is not available. You have to restore before you can get, and that's something that we can talk about right now. Actually, before we get back to that, let's do a quick overview of the CRR and lifecycle policies as well. So back into the bucket, deselecting my object here, I can add a lifecycle rule to my bucket, and we'll just call this test lifecycle. And I'll make it a bucket-wide policy, so no need to add a prefix or a tag filter here. And I will set the current version because I don't have versioning turned on in this bucket, and add a transition. So in this policy, I'd like to say that any new objects which come into this bucket, we will move into intelligent tiering 5 days after creation. And let me go back, and I'll actually add a second transition, and we'll move it into Glacier Deep Archive after. You'll see that it automatically set this to 35 days because intelligent tiering has a 30-day minimum duration, but I'd like to keep it a little bit longer here, so I'll move to Glacier Deep Archive after 90 days. We'll choose not to configure an expiration because Glacier Deep Archive is so inexpensive. It'll show us a review of the policies that we've set. You'll see here the first transition to intelligent tiering after 5 days, and the transition to Deep Archive after 90 days with no expirations. And my scope is the whole bucket because I chose not to limit this. And I'll go ahead and save the lifecycle rule. And there we have it. Similarly, you can configure replication as I discussed, and we can add a rule and walk through the same process to create an automatic replication of the data that lands in this bucket to another bucket in another region. I'll enable versioning to unlock the CRR. We'll select the entire source bucket, and I'll replicate objects encrypted using my KMS. So we'll need to find a destination bucket, and while probably not a best practice, my only bucket in another region in this account is my CloudTrail logs. We'll enable versioning there to make sure it can land. Add my KMS key, and you see we can elect to change the storage class for the replicated objects. So an important thing about the cross-region replication is you cannot cross-region replicate objects from Glacier or Glacier Deep Archive. So objects that are put into this source bucket in any frequent or infrequent access storage class will come across to the destination bucket, and we can choose to change that destination storage class to Glacier Deep Archive, and I could change the ownership if I wanted to. So we'll call this test CRR, and we'll select to enable it and create an IAM rule to own it. Again, a screen to review the rule, show that our destination storage class is Glacier Deep Archive, and I can save that. You can see back in the lifecycle screen, we have our lifecycle policy there as well. So back to the slides and a little bit more on how to get data in. Another option is the AWS Tape Gateway. AWS Tape Gateway announced support for Glacier Deep Archive at launch on March 27th. For those of you who don't know, with Tape Gateway, customers can recreate an existing tape-based workflow and store their data in S3 rather than in their own self-managed tape library. The way to think about it is when the virtual tape is in the virtual tape drive, that data is stored in S3 standard. It's available in millisecond access, almost faster than you would have an actual tape in a tape drive. Once the virtual tape is ejected from the virtual tape drive, it goes and is put on a virtual shelf. And that shelf means that the data has been stored either in S3 Glacier or Glacier Deep Archive. When you eject that tape the first time, you have the choice on which storage class it lands in. And a nice way to think about it is Deep Archive are the shelves at the back of the storage room. whereas glaciers are closer to the front. The retrieval, when you ask for the tape back, will be done using the same restore functionality that you would if you were that you would use if you were using Glacier directly. And when the data has been restored, it'll be available to you just as it was when you first put the data onto the tape. And let's not forget all the other AWS data transfer services that we offer. We offer more ways to bring data into S3 than anyone else by far. And we have a number of services beyond just the direct put, lifecycle policy, or tape gateway. We offer AWS Snowball and Snowmobiles, which are physical devices that let you move petabytes of data into S3. Once that data comes into S3, you can use a lifecycle policy or a cross-region replication policy to move those bytes into Glacier Deep Archive. Snowmobile is the only practical option to move exabytes of data into AWS. We also have over-the-wire options like Direct Connect, which is like your own private data pipe into AWS. S3 Transfer Acceleration, which is a unique way to make the internet go up to 500% faster. AWS Transfer for SFTP, if your preference is to use SFTP. And Data Sync to automate moving data between on-premises storage and S3. So we've talked about the ways to get your data in. The important part is how to get the data out, or how to access it once it's in Glacier Deep Archive. And I've talked a little bit about the differences between Glacier and Deep Archive, and think this is one of the important ones. With S3 Glacier, you have 3 retrieval tiers. Expedited, where your data comes back within 1 to 5 minutes for small objects. Standard, where your data comes back within 3 to 5 hours. And bulk, where your data comes back within 5 to 12 hours. Now again, with Deep Archive, the expedited option is not available. The standard option brings your data back within 12 hours, and the bulk option brings your data back within 48 hours. So the extending these retrieval times is really the core trade-off when you're thinking about the cost savings from S3 Glacier, which starts from 0.4 cents per gigabyte month for storage, and Glacier Deep Archive, which starts at less than 0.1 cent per gigabyte month. And on pricing, the standard retrieval pricing, both the requests and the data that comes back, it starts at twice the price of a standard retrieval request from Glacier. So in our large regions, that is 10 cents per 1,000 standard retrieval requests and 2 cents per gigabyte. And the bulk requests are actually the same as Glacier bulk. So the cost structure for the access would not change if 48 hours through bulk retrieval is acceptable for your workflow. And that price is 2.5 cents per 1,000 bulk retrieval requests and 0.25 cent per gigabyte streamed back. Again, remember, you need to request this restore before you can get the data. Behind the scenes, how it works is we retrieve the data for you and we stage it in the S3 Reduced Redundancy Storage class, RRS. When you do the restore, you're able to specify how long that data is staged for. So you can have it for a day, or you can bring it back for a full month if that's necessary. And once the restore is completed, then you can go ahead and get the object just like you would if it was in RRS or S3 standard the whole time. We think about it as a two-step process in that first you have the restore and then you have the get or the millisecond access. But another nice feature which we announced at reInvent last year is you can enable event notifications through SNS, SQS, or even Lambda functions to drive your workflows which follow behind the restore. So for example, I've got some sample code here on the screen. You could issue a retrieval, ask for that data back using a standard request, stage it for 25 days, and then have a Lambda function triggered to kick off as soon as that restore is completed with no need for additional human interaction. So let's go back to the demo and show you how that would work. Now again, I showed you how with this object which we put to Deep Archive earlier, we weren't able to access it using the URL or a GET, which would be similar. When we select this object, we can issue a restore, and we can select how many days the restore will come back for. So we'll call this one 5 days, and we'll issue it using the bulk speed to save some cost here. And the object is on its way back, and you can see if you select it again that there is a restore in progress, and you can see when it started and the tier. Like Glacier, we offer the ability to upgrade that restore speed. So if I decided that 48 hours was too long and I'd prefer to have this within 12, I could come in and I could issue a second restore, and I could upgrade to standard retrieval. It'll retain the 5-day staging that I specified. And now when I come in and I reselect, it'll show me that the restore is moving at the standard speed. Now, because we don't have 12 hours to wait, I have this object which I restored previously, and you can see here that it shows the storage classes in Glacier Deep Archive. Now, because this has been restored, it's available for a GET or a download, which I can do right here. Now, those restore notifications that I talked about are easily configured here using the Events tab in the Properties. We can add a notification, and we'll just call this a test restore notification. And you can enable a whole host of events. For this one, I'd just like to have it on a restore completed. And again, anything in the bucket, so no prefix, no suffix, you could limit to a file type or a prefix. And I could choose an SNS topic, an SQSQ, but here I'd like to choose a Lambda function. And I pre-configured a Lambda function here, which will just kick off a workflow to get and process that document once it's been restored. So now that I have enabled that event notification, this restore that's in progress here will immediately kick off the workflow that we're looking for after that's finished. So back to the slides. I'd also like to talk a bit about the support from our Amazon Partner Network for Deep Archive. AWS has twice as many integrations with storage partners compared to any other cloud platform, which means it's easy to use S3 with what you already have. And we're working very closely with a number of members of the AWS Partner Network to support Deep Archive. We're really pleased that both Commvault and Veritas offered launch day support for Deep Archive, and we hope to continue with this early momentum. We think it's really important to meet our customers where they are and make it really easy to use Deep Archive in their existing workflows. Our partners are just one way that we're able to do that. So now that we've talked about what Deep Archive is, how to get your data in, how to access your data, and how our partners are supporting us, it is important to talk about the economics a bit, because this is a great option for many workloads, but it's important to consider the total cost of ownership. So let's talk about a typical workflow here, where a customer is storing 250 terabytes. And the average object size is about 25 gigabytes. So these are large media files, which leaves us with about 50,000 objects, and their access pattern is quite low. Let's call it 0.5% a month. So we expect this customer will come in any given month and restore 250 objects, which are about 1.25 terabytes. This could be a media and entertainment archive. It could be photo or video storage, but it could be financial records or anything else. We can always retune and model any workload this way. So if you look at long-term retention costs over a year using standard retrievals when you need to access those bytes, you see the Glacier Deep Archive on the left as compared to Glacier. The ingest cost, this pricing is based on our largest U.S. regions, so Northern Virginia, Oregon, and Ohio. The ingest put requests, assuming it's a direct put, are the same. That's the same price if it was a lifecycle ingest or a CRR as well. Your storage costs are where you really see that 75% difference shine. It's just more than $3,000 for the 12 months of storage in Glacier Deep Archive, where it's more than $12,000 to keep that in Glacier. Your standard retrieval requests, even with the 2x price with Glacier Deep Archive as compared to Glacier, it's really not a large difference. It turns out to be about $300 versus $150. So you see the total cost difference of close to that 1-to-4 ratio of the storage cost, because in this particular workload, the access patterns are so low that the requests aren't able to meaningfully change the workload. Now let's look at that again if you use bulk retrievals to access your data and you're able to tolerate that extended duration. So now with bulk, we've eliminated the price difference between the retrieval requests as well as the retrieval bytes. That $150 difference has collapsed at about $38, and the total cost of ownership is still close to that 4-to-1 ratio at close to $3,000 for the Glacier Deep Archive and over $12,000 for the S3 Glacier. Now it's important to keep in mind that the gap will not close quite as quickly with increased access, but that's why it's important to consider the total cost of ownership and identify where the inflection point on each workload that you have is. There's some workloads where access is so frequent that in standard infrequent access or even S3 standard might make more sense. Intelligent tiering is a great option to bridge the gap between those two, and then as the access frequency reduces, Glacier and then Deep Archive become compelling options. So just talking about all the storage classes and thinking about how they compare along a few different vectors is important. And access time is one of the most important considerations here. Again, all of the S3 frequent and infrequent access classes offer access to your bytes in milliseconds. And while there might be a slightly different cost structure, you can get those bytes very, very quickly to run analysis on or to serve to a customer or anything like that. Glacier can give you access in minutes to low single-digit hours and 12 hours at the longest. However, Glacier Deep Archive sits behind Glacier in that it could take you anywhere from 12 to 48 hours to have access to those bytes back, which is an important part of the value proposition to consider. After how quickly, it's also important to consider how much it'll cost to retrieve those bytes. And again, frequency of access is an important variable here. With S3 standard, you can see the storage costs, which are y-axis here, are much higher. However, the retrieval costs are quite low. When you get to infrequent access, you see that the storage cost has reduced, but the retrieval cost has increased, and Glacier and Deep Archive continue that trend. So again, the increased standard retrieval cost with less access becomes less of a factor in the total cost of ownership. However, as the access increases, it's important to think about the retrieval as well as the storage and make sure that you're not choosing without properly considering all factors. A few final factors on the economics which are important to consider. As I mentioned, each workload does have an inflection point between storage classes, and it's really important to identify where yours is so that you can choose the right storage class, particularly when you're considering moving bytes into Glacier or Deep Archive, because it's something that we at Amazon like to call close to a one-way door. And that is, once you put the data into Glacier or Deep Archive, it's not easy to move it back out into something like S3 standard and frequent access. You'd have to restore the data. There would be a cost associated with those requests as well as the bytes streamed back, and it would take time. It's not as easy as saying, oh gosh, I didn't mean to choose this bucket. I'd like to move it into a different class. So it's important to do that analysis before you land the objects in that bucket. And also to keep in mind what you expect your patterns to be and to think about using lifecycle policies to automatically move the data into the appropriate class at the appropriate time. Another thing to consider is small objects. Small objects can create a challenge with Glacier and Deep Archive for two reasons. One is because we charge per object on both the ingest and the access. So if you have a higher volume of small objects, your ingest costs will be higher than if you had a lower volume of larger objects. But Glacier and Deep Archive also deal with small objects in a slightly different way than the other S3 storage classes. S3 Intelligent Tiering and Infrequent Access has a minimum object size of 128 kilobytes. And the way that's implemented is a lifecycle policy will not move your object into an infrequent access class unless it's 128 kilobytes or larger. While you can directly put an object into an infrequent access class, you'll be charged for a full 128 kilobytes if you do. So many customers elect not to put smaller bytes directly into those classes. Glacier handles it slightly differently, as does Deep Archive, in that we won't restrict those objects from moving in with a lifecycle policy, and we won't charge a minimum storage size. What we do instead with Glacier and Deep Archive is we include a chargeable overhead per objects. So again, lots of small objects, more chargeable overhead. And the way that is implemented is it's a 40 kilobyte chargeable overhead. 8 kilobytes of that is charged at the S3 standard rate in the region, which can be one of three prices depending on the volume of usage in your account. The other 32 kilobytes are charged at the same storage price that the object is in. So if that's a Glacier object, it's 32 kilobytes at the Glacier storage rate. If it's a Deep Archive object, it's 32 kilobytes at the Deep Archive storage rate. And again, with a lot of small objects, say your object is only 50 kilobytes, now you're paying not for 50 kilobytes of storage in Glacier or Deep Archive, you're paying for 82 kilobytes, and you're also paying for 8 kilobytes in S3 standard at a higher storage cost. A recommended way to solve this is to aggregate your objects. So I've included this little graph on the screen here with a sensitivity table, which shows what your ingest cost would look like for an example that's fairly similar to the one that we just talked through in the other economic example, but assuming that those files were 25 kilobytes instead of 25 gigabytes. You can see the ingest cost, if you put those all individually into Deep Archive, is very, very high. It's more than $500,000. But if you aggregate just at a 1 to 10 ratio, you reduce that ingest cost by an order of magnitude. And if you're able to aggregate at a 1 to 50 or a 1 to 100 ratio, you can really meaningfully reduce that cost to the point where it's much less of a needle mover in the total cost of ownership. So with small objects, aggregation is something that's really important to take a hard look at. And the last piece is the duration of storage. Remember, there is that minimum retention period. It's 180 days for Deep Archive. It's 90 days for Glacier. However, the longer you keep the objects, the more time you have to enjoy the benefit of that ingest price. So if you're making some transitions into Glacier or Deep Archive and you only expect to keep that data for 6 months, maybe it's worth running an economic model of, could I just keep it in the storage class where it currently is, and how long would it take for me to reach the point where I'm actually saving total cost when accounting for the lifecycle request or the put request or whatever the ingest cost looks like there. So having gone through the economics, I think it's also important to highlight some example use cases just to give you a sense of what our customers are using Deep Archive for today. And I think the classic example is disaster recovery. We have many customers that use cross-region replication to store a backup copy in another region, and they go directly to Glacier. The adoption of that after we announced the ability to cross-region replicate directly to Glacier at reInvent in 2018 was terrific. Customers were using it before that by just cross-region replicating into S3 and using a a zero-day lifecycle policy in the destination bucket. So for those of you who are using cross-region replication, I think that secondary copy, particularly where you don't have a need, you don't expect to need to pull that back and you don't have a need to access that quickly, it's a great idea to look at those cross-region replication policies and think about, is there a subset of tags or maybe a whole set of buckets where it makes good sense to update the destination storage class to be Deep Archive? Another example is original media content. For example, there's a 12K video. It's a huge file, and there are many other processed copies of that available, stored in other systems. It's a great way to say, I just want to keep a second copy of this really rich, very valuable, but large media, and make sure that there is no chance we're losing this valuable content. The same goes for music or podcasts or photographs, any other type of media. Another great use case is legal, medical, and financial records. Many of these things have really long required durations. Things like life of the patient, life of the loan plus 7 years. It could be 37 years in the case of a mortgage. Life of the republic, which sounds like forever to me. And many of these things need to be kept in a state where they cannot be modified. And we do offer S3 object lock to help customers who have those needs. And object lock applies to all S3 objects regardless of storage class. So it includes S3 Glacier Deep Archive. But the important part is that object lock can attach to your objects independent of that object being moved with a lifecycle policy. So if you do have those types of requirements, you can use object lock and still set a lifecycle policy to transition that storage into Deep Archive and enjoy the low price. And the last example is machine learning training data, things like autonomous vehicles, drones, any type of research. So the value of being able to access that data at some point in the future when there's a new analysis or to train a new model or something like that, Deep Archive is a great way to keep those costs low. Again, offer you the option to restore it using a bulk request at a low price back into our millisecond access reduced redundancy class so that you can train a new model or do some comparative analysis and have access to that data and the value it provides rather than shipping it off to an offsite storage facility where there's a great chance that it may come back in an unusable state. With that, I'd like to thank everyone for your time today, and we'll take some questions in the chat and look forward to your feedback on Deep Archive. Thanks.